Welcome back to my series of short video about load calculation manual J. Today what I want to touch on is air infiltration. There are many tools that will measure the air infiltration going into your house in CFM. But the load calculation is the only one that will allow you to compare the benefit of stopping the air infiltration versus replacing the insulation or adding insulation in the attic versus replacing the window versus doing something else. It's good to stop air infiltration, but is there really a benefit for your house in your climate? That's what I want to check today with the load calculation. So let's go ahead. So we still work on that 30-year-old home in the Dallas-Fort Worth area with vented attic and the duct in the attic. So if you've watched my previous video, you already know the house. So this is the house. So we've got concrete slab, R21 of insulation in the attic, 2x4 wall with R13 of insulation between the stud, and then aluminum windows. So this is our original house. Now this is a 30-year-old house. So back then construction was fairly loose, so a lot of air infiltration. So I've got loose construction under my construction type. Now we're going to try to move that, and it's a retrofit, so we're limited to what we can do. But for the exercise, I'm gonna go from a loose construction to an average construction, and then we're gonna see how it improve our load calculation. So before we do that, I want to show you quickly what the manual J means by loose and average, and this is the definition of a loose construction by the manual J, average construction, and tight construction. And I think loose reflects pretty well what was done about 30 years ago, at least here in Texas. So let's move on and check what the load is now that we fixed our infiltration. Okay, there you go. So this is our new load. Okay, so in a summer, or remember, summer is net gain. We are gaining 53,595 BTU of heat. So 53,000 BTU of heat is entering the house in the summer. And then in the winter, the house is losing 70,229 BTU of heat. So how does that compare to original house? Well, again, I've got a side-by-side view. On top here, this is the original house. So in the original house, before we stopped any air infiltration, in the summer, the house is gaining 57,791 BTU of heat. Now that we've stopped the air infiltration, we're gaining 53,595 BTU. So we've gained about 4,000 BTU. With 4,000 BTU of heat less is entering the house now that we've stopped the air infiltration. But if we look in the winter, on the original house, we're losing 80,714 BTU of heat. And now that we've stopped air infiltration, we are losing 70,229 BTU of heat. So we actually improve the efficiency by 10,000 BTU. So the first thing that jump is there's a greater benefit to stopping air infiltration in the winter than in the summer. Okay? But it's not that simple, because there is two types of heat gain in the summer. We have sensible heat, which is dry heat, and we have latent heat, which is humidity. So now if you compare the two, before we stopped air infiltration on the original house, we're gaining 6,500 BTU of humidity. So now that we stop air infiltration, our humidity entering the house in the summer is down to 4,925 BTU. So that's a 25% gain from the original house, which sounds like a lot, but the numbers are small. Now if you look at the dry heat, we only gained 5%, so it's not that much. And I think the lesson to learn here, if you live in a humid climate, I'm thinking Houston, New Orleans, Miami, all the places in the West Coast, where you have over 45% of humidity in the summer, you want to try to stop air infiltration the best you can. You want to spend money on trying to stop air infiltration. Same if you live in a cold climate. If your heating bill is higher than your cooling bill, you want to try to spend money on trying to stop air infiltration. But if you're like in between, you know, you're in a 32% range humidity in the summer, I'm not sure you want to tie up your money trying to stop air infiltration. There are probably other things you gotta do before you worry about air infiltration. And that's the benefit of the load calculation. It will give you that information. Now, it won't measure the amount of air infiltration in CFM entering the house. But then the blow-door test will do that. But when you know the amount of CFM entering the house, what do you do with that information? How much does it change your load? You don't know that. Only a load calculation will show you that. And in some climate, if you have some air infiltration entering a house, it's not as big of a deal. In other climate, it's a big deal. You need to stop the air infiltration. So that's why everyone should have a manual J or a load calculation. So to order your load calculation, you can go on my website, go on my load calculation page, and at the bottom of the page, you know, I've listed all the information that I need to do an accurate load calculation. So thank you again for watching my video, and I hope I'll see you soon.